going on? Welcome back, day 44. Nice job with matching the graphs today. I know that's kind of a tall task. My hope is that you guys are getting way more comfortable looking at these graphs and interpreting them. Today, not going to be too much new. We haven't really analyzed a lot of F double prime graphs, so we're going to do that today, so that's new. But I want us to analyze an F prime graph and an F double prime graph and be able to answer or just tell everything we can about F. We want to know everything possible about F. Okay, so also, I forgot again on the giveaway today. Let's do that on Monday. I know tomorrow there's a bunch of people absent for the UST thing, so let's look at that on Monday. I will do my absolute best to remember. I apologize. Mea culpa. Okay, so let's take a look at an F prime graph. Go ahead and pause the video for a second and copy this graph into your notes. And let's talk about it. Let's talk about everything we know about about F based on this graph. Okay, so the first thing I like to do to prevent making any stupid mistakes, I like to, since not all of the x values are labeled here, I'm going to go ahead and label all the x values, just so we don't make any dumb mistakes with that. Okay. So this F prime graph we can see is only defined from -7 to 7. So I want to answer everything possible I can ever know about F. Okay. And I'm going to go in the order that we learned them. So I'm going to start with increasing and decreasing. Then I'm going to move to critical points and critical point analysis. Then I'm going to move to concavity. Then I'm going to move to inflection points. Okay? We can tell all of those things based off this one graph. On the test, you're going to have to know all of them. Maybe not all of them on one particular problem, but all of those concepts will be tested somewhere on the test, so we need to be able to do all of them really well. So let's start with F increasing. Based on this F prime graph here, I want to know when is F, on what intervals is F increasing. Okay. Well, again, to know F increasing, I have to know when F prime is positive. I have a graph of F prime, so I'm simply going to look, where is this graph above the x-axis? Well, that would be on the interval from -7 to -5, union 4 to 7. We need to be able to do that every time without fail. The next question I'm going to ask is, where is F decreasing? This can be done a couple of different ways. It depends on if we include -1 in our decreasing. Oftentimes what the AP test does, if it was multiple choice, they would say from -5 to -4. But I'm okay with you splitting that up with -5 to -1, union -1 to 4. Do we include that -1? Some mathematicians argue we do. Some mathematicians argue we don't. So I'm going to write this as, but again, where is F decreasing? F decreases anytime F prime is less than 0. So I want to report where F prime is negative. So I'm going to say from -5 to -1, union -1 to 4. Again, labeling my axes, my x-axis there, ensures that I don't make any mistakes with those numbers. Okay. Next, critical points of F. And then I want to classify as relative max, relative min, or neither. And I want to justify. Well, I guess I didn't justify on the first one, right? What would be our justification for f increasing? -7 to -5, union 4 to 7. Well, that's where f prime is greater than 0. Please don't say where it is greater than 0. We want to be specific. Okay, so let's talk about critical points of f. Critical points of f occur anytime f prime is equal to 0. That is a definition that you have to know. Critical points of f occur when f prime equals 0 or f prime is undefined. Since nothing here is undefined, I don't have to worry about that. I'm just looking for the zeros. So here are the three I get. X equals -5. I get x equals -1. And I got x equals 4. Now I want to classify them. X equals -5, okay? I can tell right away that this is going to be either a max or a min because I actually crossed the x-axis, right? I actually crossed the x-axis. But how do I change? How does my f prime change? That really matters here. Well, I always move left to right. That's first off. We always move left to right, just like reading English. On the left side, f prime is plus. On the right side, f prime is minus, right? Therefore, f prime went from plus to minus. So we know that we have a local max. Right. If we needed to justify, we'd say f prime switched plus to minus. How about -1? Well, this is neither a max nor a min because f prime didn't switch signs. X equals 4. F prime did switch signs. To the left of 4, f prime was negative. To the right of 4, f prime was positive. We know that means that we have a local min. Again, because f prime switched minus to plus. I want you guys to be very, very, very comfortable with f increasing, f decreasing, and critical points, and determining whether or not those critical points are local mins, maxes, or neither. I just want to add a little justification to the first two I did, just to be good here. F is increasing on that because f prime greater than 0. F is decreasing here because f prime is less than 0. Okay, now let's move on to concavity. So let's talk about f being concave up. When is f concave up? On what intervals is f concave up? Well, for f to be concave up, f double prime must be positive. Well, we don't have f double prime, so let's think of concavity's definition in terms of f prime. F is concave up anytime f prime is increasing. So when is f prime, the graph I'm looking at, when is this graph increasing? Well, I'm going to say from -3 to -1, union, -3 to -1, union 2 to 7. My justification, that's where f prime is increasing. Okay? So not only can we tell whether f is increasing or decreasing, or whether f has a local min-max or neither, we can also tell where f's concavity based on this graph. F had to be concave up on my sketch from -3 to -1, union 2 to 7. My next question is obviously going to be, when is f concave down? F is concave down. That's going to be anytime f prime is decreasing. right? Because that's going to make F double prime negative. So F prime is decreasing from -7 to -3, union -1 to 2. Those two stretches there, F prime is decreasing, so -7 to -3, union -1 to 2. Again, my justification, that's where F prime is decreasing. Last thing I'm going to ask about are inflection points. Inflection points occur when we change concavity, right? Looking at our intervals here, we can see the numbers where concavity changes, right? Where do my intervals switch from concave up to concave down or vice versa? Well, I started out concave down from -7 to -3. Then I switched to concave up from -3 to -1. So that -3 must be a place where I have an inflection point of F. So again, it's IP of F. Then I switch again at -1, then I switch again at 2. Looking at the graph, inflection points occur when F prime switches from decreasing to increasing, right here. F prime also switched from decreasing to increasing right here. Or vice versa, F prime switching from increasing to decreasing, right? I'm looking for those local maxes and mins of F prime will be the inflection points of F. So I'm going to report those 3 x values, -3, -1, and 2. Notice, increasing and decreasing are intervals. Concave up, concave down are intervals. Critical points and inflection points are x values. They're not intervals. So x equals -3, -1, and +2. My justification, this is where F prime switches, not signs, but switches from decreasing to increasing. Or vice versa. Okay. We want to be absolute master analyzers of F prime graphs, right? All of us, every single person should be able to look at an F prime graph and immediately know where F is increasing, where F is decreasing, the critical points and what type they are of F. We need to know where F is concave up, where F is concave down, and we need to know the inflection points of F. We can do that day in, day out, over and over and over again because we know our definitions really well. Now let's switch to an F double prime graph. We worked a little bit with F double prime. We worked with F double prime today in class a little bit in our matching category. But let's figure out what can we know about F based on an F double prime graph. Okay. Well, there's only 3 things that we can figure out. I can figure out where F is concave up, I can figure out where F is concave down, and I can figure out where my inflection points are. I do not have enough information to tell where F is increasing or decreasing, and I don't have enough information to tell the critical points of F. So let's go ahead and number our axes just like we did last time. Again, the second derivative is really good at telling us about concavity and inflection points. Okay, so let's take a look. Once again, this graph is only defined on -7 to 7. Okay, so my first question is, when is F concave up? Now let's think about our definitions of concave up. Concave up is when F is smiling. We don't have a graph of F, so we don't care. What we did on the last problem, F is concave up when F prime is increasing. That doesn't matter here because I don't have an F prime graph. I have an F double prime graph. Concave up's definition for F double prime is greater than 0. So if I want to know where F is concave up based on this graph, I need to look at where this graph is positive because I want to know F double prime greater than 0. Okay? For concave up in graphs, we need to know two definitions. For an F prime graph, F prime is increasing. For an F double prime graph, F double prime is greater than 0. Okay, so I want to report where on this graph, F double prime graph, am I greater than 0? Right, because we have F double prime. Well, we're going to be concave up from -4 to 0, union 0 to 5. Again, my justification, this is where F double prime is greater than 0. That was the first definition of concave up that we looked at. F double prime is positive. This graph is positive from -4 to 0, union 0 to 5. How about F being concave down? F is concave down. Well, if F is concave up when F double prime is positive, F is going to be concave down when F double prime is negative. So what parts of this F double prime graph are negative? Well, from -7 to -4. Union 5 to 7. Again, my justification, that's where F double prime is less than 0. Last thing I want to look at is inflection points of F. Inflection points of F are when F double prime switches signs. That was the first definition we learned. Inflection points of F are when F double prime switches signs, when I change concavities. Or we could think of it as where F prime goes from increasing to decreasing or vice versa. Well, that would be great if I had an F prime graph, but I don't. I have an F double prime graph. So where does F double prime switch signs? You might think there are 3 points, but there are only 2 points. 0 is not an inflection point because F double prime didn't change signs. F double prime hit 0, but it never changed signs. F double prime changes signs at x equals -4 and x equals 5. Justification, that's where F double prime changed signs. And that is it for this video. Hopefully it wasn't too long. I'll see you guys tomorrow. If you're doing the UST thing tomorrow, have a great time. Talk to you guys later. 2 chains. Bye. Didn't forget the bye this time.